The sketch graph shown here shows a line joining the 2 points A and B with coordinates x1, y1 and x2, y2. Now, you can find the distance d between the 2 points A and B by considering the right angle triangle with hypotenuse AB. Before we learn how to find the distance d, let's take a quick look through the Pythagoras Theorem. As you can see here, this is a right angle triangle. The names of the sides of this right angle triangle are hypotenuse, opposite and adjacent. The hypotenuse of a right angle triangle is always the side opposite the right angle. So now this is the hypotenuse. It is the longest side in a right angle triangle. So if we label this angle as theta, the opposite side of this angle is this side. The opposite side is the one across from a given angle. Now, this is the adjacent side if we look from this angle. An adjacent side is next to a given angle. Now, if we label this angle as theta, if we look from this angle, this is the adjacent and this is the opposite side and this is the hypotenuse. Now, if we take a look at the Pythagoras theorem states that in a right angle triangle, the square of the hypotenuse side is equal to the sum of the squares of the other two sides. So, the square of the hypotenuse is equal to the square of the opposite plus the square of the adjacent. So, if we label this triangle as ABC, then AB squared equals AC squared plus BC squared. As I said earlier, you can find the distance between the 2 points A and B by considering the right angle triangle with hypotenuse AB. So, you can find the distance d between the points with coordinates x1, y1 and x2, y2 by using the formula d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. This is because we use the Pythagoras theorem. So, hypotenuse squared equals opposite squared plus adjacent squared. So, here the hypotenuse is AB, or you could say D. And the other two sides are x2 minus x1 and y2 minus y1. So, using the Pythagoras theorem, D squared equals x2 minus x1 squared plus y2 minus y1 squared. Take the square roots from both sides. So, D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, let's take a look at a few examples. Find the distance between these pairs of points, 3, 1 and minus 1, 4. So, using this formula, we can find D. Then, D squared equals minus 1 minus 3 squared plus 4 minus 1 squared. D squared equals minus 4 squared plus 3 squared. D squared equals 16 plus 9. D squared equals 25. Then, D equals 5. 0, 1 and 6, 9. So, D squared equals 6 minus 0 squared plus 9 minus 1 squared. D squared equals 6 squared plus 8 squared. D squared equals 100. D equals 10. The line 7x plus 5y minus 18 equal to 0 crosses the x-axis at the point A and the y-axis at the point B, and O is the origin. Find the area of the triangle AOB. So first, let's find the coordinates of A and B. The line 7x plus 5y minus 18 equal to 0 crosses the x-axis at the point A. This is when y equals 0. So, when y equals 0, 7x minus 18 equal to 0, x equals 18 over 7. So, the coordinates of A are 18 over 7, 0. The line 7x plus 5y minus 18 equal to 0 crosses the y-axis at the point B. This is when x equal to 0. So, when x equal to 0, 5y minus 18 equal to 0, y equals 18 over 5. And hence, the coordinates of B are 0, 18 over 5. Now, just for reference, let's draw a sketch. So, as you can see, the triangle made here is a right angle triangle. So, you can use the formula for finding the area of a right angle triangle here to find the area. The formula is half times base times height. The triangle has a height of 18 over 5 or 3.6 units and a base of 18 over 7 units. So, the area of the triangle AOB is half times 18 over 7 times 18 over 5 equals 324 over 70 equals 162 over 35. Remember, you don't have to give units for length and area problems on coordinate grids. The points R 5, minus 2 and S 9, 0 lie on the straight line with equation y equals 1 over 2x minus 9 over 2. The straight line y equals minus 2x plus 8 is perpendicular to the line y equals 1 over 2x minus 9 over 2 and passes through the point R. The line y equals minus 2x plus 8 crosses the y-axis at t. Work out the area of the triangle RST. So now here is the sketch of the two graphs. First, let's work out the coordinates of t. So, when x equals 0, y equals 8 and hence the coordinates of t are 0, 8. As you can see, the triangle RST is a right angle triangle. But to find the area here, it is not simple as to use in the coordinates like in the previous example. So first, let's work out the lengths of RS and TR. So the coordinates of R and S are 5, minus 2 and 9, 0 respectively. And hence, the length of RS is RS squared equals 9 minus 5 squared plus 0 minus 2 squared. RS squared equals 4 squared plus 2 squared. RS squared equals 20. RS equals 2 square root 5. Now, to find the length of TR, the coordinates of T and R are 0, 8 and 5, minus 2 respectively. Then, TR squared equals 5 minus 0 squared plus minus 2 minus 8 squared. TR squared equals 5 squared plus minus 10 squared. TR squared equals 125. TR equals 5 square root 5. Now that we know the lengths, we can use the formula half times base times height to find the area. So, the base here is RS and the height is TR. So, the area is half times 2 square root 5 times 5 square root 5 equals 25.